Operating system. All modern computers have some form of operating system which users generally take for granted. The operating system makes it possible to communicate with the software and hardware that makes up a typical computer system. An operating system, also known as OS, controls the general operation of a computer and provides an easy way for us to interact with computers and run applications. So as you already know, when you use a computer, you use an operating system. So here is the user. Of course, you have the operating system. And of course, when you use an operating system, you use also application software. And for example, when you use your laptop, even your PC, you have also hardware. So the operating system makes it possible to communicate with the software and hardware that make up the computer system. And the OS, what does it do? It controls the general operation of a computer and provide an easy way for us, that is a user, to interact with computers and run applications. The operating system provides an interface between the user and the computer hardware. When a computer is switched on, the initiating programs are loaded into the memory from the ROM chip. These programs run a checking procedure to make sure the hardware, processor, internal hardware, and BIOS, which means basic input-output system, are all functioning correctly. If no errors are detected, then the operating system is loaded into memory. Without the operating system, most computers would be user-unfriendly and useless. So here we are going to see some common examples of operating system, the most popular ones. We have Linux for personal computers, Unix for mainframes, Microsoft Windows such as XP, Vista, Windows 10 for personal computers, Android for mobile phones, Macintosh or macOS for Mac computers, iOS for mobile phones, and this operating system, also known as DOS, for personal computers. Types of interfaces. The means of communication between the user and the machine is known as the user interface and consists of both hardware and software. It consists of hardware and software through which a user provides input to a computer or receives information from it. There are different types of interface which are useful in different situations and for different types of users. Here we are going to see some examples of the types of interfaces. We are going to see graphical user interface, menu-based interface, form-based interface, and command line interface. The first type of interface that we are going to see is the graphical user interface. Graphical interfaces are called GUI, that is Graphical User Interface, or WIMP, Windows Icon, Menus and Pointer, because it displays graphics as well as text. A GUI is very user-friendly. The user will expect to be able to select options by use of menus of choices and by using small pictures which represent the different options available. Choices are selected by the user by using some sort of pointing device to indicate choice. Typically, this would be a mouse. The second one is menu-driven interface. A menu-driven interface is commonly used on cash machines, also known as automated teller machines, ATMs, ticket machines, and information kiosks, for example in a museum. They provide a simple and easy to use interface comprised of a series of menus and submenus which the user accesses by pressing buttons, often on a touchscreen device. Preferably, if one has knowledge of UML modeling, it can be a good example when designing the architecture of the machine. The third one is form-based. A form-based interface uses text boxes, drop-down menus, text areas, check boxes, radio boxes, and buttons to create an electronic form which a user completes in order to enter data into a system. This is commonly used on websites to gather data from a user or in call centers to allow operators to quickly enter information gathered over the phone. The fourth one is a command line interface. also known as command-based interface. It is one where the user types a series of commands at the keyboard which tells the computer what their intentions are. The user needs to know what the possible commands are and needs to understand the way files are stored on the system. The characteristics of a command-based interface are: the user needs to know what commands are available, the user needs to understand the commands, and the user needs to understand the way that materials is stored in the computer system. So here is a picture of a command line interface. Because of the above point, that is the characteristic mentioned before, there are two very important characteristics about a command-based interface. First, the system is very much open than the other types of interface. Other interfaces restrict the options that the user has available to them. This can be particularly important for the system manager because different users can only be allowed to have access to specific parts of the system. The second characteristic is that command-based interface can only be used by computer literate people because you not only have to understand the commands and their uses, but you also need to understand something about how the computer operates and more particularly how information is stored. So the operating system is designed mainly with a single user using the computer at a time, but can have many applications open simultaneously. For example, you might be writing an essay while searching the internet, downloading a video file, and listen to a piece of music. This refers to as a single user multitasking operating system. Household appliances such as cookers, microwaves, oven, and washing machines are embedded with microprocessors and do not require any operating system. The appliances require simple inputs such as a keypad on front washing machine or touchscreen option selected, which activates a simple hardware function which does not need an operating system to control it. The initiating programs are loaded into memory from the ROM, that is a read-only memory chip, which stores the whole instruction set as microprocessor has just one set of tasks to perform. Types of operating system. The first one that we are going to see is real-time transaction processing. It is an OS that has to react instantly to an input. Real-time transaction processing system is used in booking system to avoid double booking. For example, when a user books a seat in a flight, the database is updated instantly so that the same seat cannot be booked again. Example of real-time transaction processing system are: we have booking of seats in theater and stock control. The second one is real-time process control operating system. It is usually used in computer control system and makes use of sensors and feedback loops to monitor and control processes. Examples of use of real-time process control are: control the level of water in a tank, monitoring and control temperature in a greenhouse, and aircraft control. So what is the difference between real-time transaction processing and real-time process control? In real-time transaction processing, files are often updated instantly, for example when booking seats on an airplane. But in real-time process control, physical quantities such as temperature are continuously monitored and the input is processed sufficiently quickly to be capable of influencing the data source. Next one is the batch processing operating system. A batch processing operating system is where jobs are collected together in a batch, that is in a group, and processed in one go. Typically, the processing of payrolls, electric bills, invoices, and daily transactions are dealt with in this way. This method of operation can be used with jobs of similar inputs, processing, and outputs where no human intervention is needed. Jobs are stored in a queue until the computer is ready to deal with them. Often batch processed jobs are done overnight. Next one is multitasking OS. Multitasking OS refers to an operating system where multiple jobs can be executed by the CPU simultaneously by switching between them. Switches occur so frequently that the user may interact with each program while it is running. Next one is multi-programming. It is an OS where two or more programs reside in memory at the same time and share the processor. Multiprogramming assumes a single shared processor. It increases CPU utilization by organizing jobs so that the CPU always has one to execute. Next one is distributed operating system. Distributed system uses multiple central processors to serve multiple real-time applications and multiple users. Data processing jobs are distributed among the processors accordingly to perform each job most efficiently. The last one is the network operating system. The network operating system runs on a server and provides the server the capability to manage data, users, groups, security, applications, and other networking functions. The primary purpose of the network operating system is to allow shared file and printer access among multiple computers in a network, typically a local area network, LAN. Now we are going to look at the functions of operating system. It allocates a time slot with the processor for each job that needs to be processed. It helps in the loading and unloading of programs. It provides a user interface so that we can interact with the computer. It manages applications that are running on the computer, is starting them when the user requests and is stopping them when they are no longer needed. It manages files, helping us save our work, organize our files, find files that we have saved and load the files. It manages the computer's memory, deciding what should be loaded into the memory and what should be removed. It creates a working environment. It provides utility programs. It handles the computer's input and output hardware such as keyboard, printers, etc. It organizes processing time between programs and users. It provides error handling. For example, if a printer is jammed and cannot print, the operating system will stop the print job and alert the user with a warning message. It maintains security and access right of users, and it also handles interrupt. Now we are going to see what is an interrupt. An interrupt is a signal generated by a device which causes a break in the normal execution of a program. It is a signal from a device to the processor to indicate that it wants attention. For example, an error has occurred such as a paper jam in a printer, a user pressing a key on the keyboard such as the Ctrl, Alt and Break keys, a software error, for example, executable file could not be found to initiate the execution of a program, and a hardware malfunction, for example, wrong input-output port. Now we are going to see about how do we handle an interrupt, so handling interrupt. So once the interrupt signal is received, the processor either carries on with what it was doing or stops to service the program or device that generated the interrupt. Whenever an interrupt is serviced, the status of the current task being run is saved. This is done using an interrupt service routine, sometimes called as interrupt handler. Once the interrupt has been fully serviced, the status of the interrupted task is reinstated, and it continues from the point prior to the interrupt being sent. Utility program. Utility programs are part of the operating system of a computer and are routines which carry out important tasks which are necessary from time to time on the system. They do not produce a pretty picture or a letter which can be sent to someone, so they are not application programs. But the types of job that they do are so important that the system could not run without them. Utility program is system software that carry out routine tasks such as file compression, that is compressing a file to save space on backing storage, encryption, decryption, checking a disk for fault and repairing them, disk defragmentation, that is defragmenting a disk to rearrange space, formatting to delete all files, that is formatting the disk, backing up and restoring data, that is recovering data from damaged files, and antivirus software, checking the files on a disk for computer viruses. So here we are going to look in more details about file management. Another part of the operating system is the file manager. While the memory manager is responsible for the maintenance of primary memory, the file manager is responsible for the maintenance of secondary storage, for example, hard disk. So the operating system is responsible for the following activities in connection with file management. We have file creation and deletion, directory creation and deletion, support for manipulating files and directories, mapping files onto secondary storage, file backup on a stable non-volatile storage media, identify and locate a selected file, use a directory to describe the location of all files plus their attributes. On a shared system, describe users' access control, blocking access to files, provide simple and fast algorithms to read and write files, give and deny access rights on files to users and programs, allocate and delocate files to processors, and the last one we have, provide users and programs with simple commands for file handling. Buffer. A buffer is a temporary storage space where data can be held and processed. When the buffer is empty, an interrupt signal is sent to the CPU which swings by and fills it again. The peripheral must wait during this filling stage. Buffers are used, for example, when streaming a video from the internet. As data for a file is downloaded, it is held in the buffer temporarily. As soon as the data is in the buffer, the file will start playing. So when you see the warning sign buffering, this means that the client is waiting for more data from the server. The buffer will be smaller if the computer is on a faster network. Polling and handshaking. So we are going to see polling first. So method in which operating system periodically checks each peripheral device for communication is called polling. And handshaking, it is a term used to describe the process of one computer establishing a connection with another computer or device. The handshake is often the steps of verifying the connection, the speed, or the authorization of the computer trying to connect to it. Checksum. A checksum is a way of summarizing a block of data such as a USB or network data packet. At its simplest, it consists of the arithmetical sum of all the numerical values of all the elements of the block. The sum reduced to a standard number of digits and transmitted with the block. So when the block of data gets to its destination, the same mathematical calculation is performed on the data by the received device and the result is compared with the received checksum. If the two checksums match, the integrity of the data has been maintained. However, if the two checksums do not match, then an error has been made in transmitting the data and the receiving device requests the sending device to retransmit the data. Even if one binary digit has changed in the data, the recalculated checksum does not match the received checksum and the data are rejected.